Hello everyone, today let's solve the problem animals, right? So this was asked in the Codeforces beta round 35 for the division 2. So what the question states here, we have n days and an initial stock of x tons of food. So just give me a second here, 1 second, sorry, 1 second. We have what we have been given n days and initial stock of x tons of food. So this is nothing but the tons of food, right? So we have n days and an initial stock of x tons of food. So one day I means one indexed here, I is one indexed. One day I one animals arrive that if accepted eat ci means one day I one animal arrives that if accepted eats ci basically tons every day from the day I through day n, right? So again I'm gonna say this one, repeat this one. Sorry, I said it wrong, I guess. So we have n days and an initial stock of x tons of food. I was thinking some other thing. Just give me a second, man. I'll just read out this one from the beginning basically. We have n days and initial stock of x tons of food here. So on the day I, nothing but the one indexed, one animal arrives that if accepted eat ci tons every day from day I through day n, right? So this is simple. On the day I, one animal arrives that if accepted eat ci tons every day from day I to day n basically, right? So this is fine. Now we may accept or reject each animal immediately. Rejected animals never eat anything, right? So we may accept or reject, right? So yeah, we may accept or reject each arrival immediately. We have been always rejected, so just keep this in mind. We may accept or reject, right? So we may accept or reject each arrival immediately. Rejected animals never eat. So this is very important, man. Rejected animals, what they do? They never eat, right? So yeah, on day I, one animal arrives that if accepted eats C items every day from day I through day n, right? So we may accept or reject each animal immediately and the rejected animals never eat, right? So no one should be unfed. So here no one should be unfed and we want to maximize the number of accepted animals, right? So no one should be unfed and what we need to do, we have to maximize the number of accepted animals, right? So maximize number of accepted animals means people this one animals has to eat. So rejected animals never eat, right? So we have to maximize the number of this one accepted animals. Equivalently we have to pick the subset without sorry, with total lifetime food. Nothing but in this case I can just represent in this way, sigma ci here into n minus I plus 1, that is nothing but less than or equal to x basically, right? So this one I can consider less than or equal to x basically, right? So I'll just read out the question load, just try to understand this one. So we have n days and an initial stock of x tons of food. We know this. On day I, one animal arrives that if accepted eat ci tons every day from the day I through day n. So we may accept or reject each animal immediately, each arrival or the animal immediately, right? So rejected animals never eat, right? So no one should ever be unfed. No one should ever be unfed and we want to maximize the number of accepted animals. Equivalently pick a subset with total lifetime food, right? So this we can consider ci this one into n minus I plus 1, that should be less than or equal to x basically. So this is the question mainly, right? I hope the question part is completely clear, man, right? Now let me come to the input output part here. So just give me a second here. Let me come to the input output part. So as I've said, I just want to tell you one thing. We didn't consider this one yet. So we will be going with a dynamic programming to solve this problem, right? So we will be going with dynamic programming, right? So I'll just write here programming, right? So to solve this particular problem, just keep this thing in mind, right? Let's discuss the approach step by step. Then let's discuss the complexities and then let's write the code. As usual, let's discuss the approach first. So now I have considered the same first example that they have given in the question, right? So here we have been given 3 and 4, 1 1 1. The output that we need to get here is 2, right? So as I've said, we'll be going with a dynamic programming approach. So let's move on with a step-by-step explanation here. So we have n3, x is 4 and c is 1 1 1. This one, n x and this is c, right? So this is fine. So accordingly with the question, each accepted animal on the day I costs ci into n minus I. So this one I have said this one in the question itself, right? Here costs are nothing but 3 to 1, right? So we are going with a ci into n minus I. Costs are nothing but 3, 2 and 1, right? So let's define dp of ij, nothing but here in this case minimum total food that is needed to accept exactly j animals among the first I days, right? So we will initialize dp of 0, 0 to 0, initialize, right? So we are going with the initialization dp of 0 0 to 0 and others to x plus 1 and others to x plus 1. Just remember this part, right? So this is fine, man. Now for that, let's go with the transition for day I. So we are going with dp of I plus 1 into j minus j plus 1, right? So we will be going with min of dp of I plus 1 into j plus 1, dp of ij plus ci into n minus I. So this part is very important, right? So same thing, dp of I plus 1 j plus 1 and dp of ij plus this formula ci into n minus I. If this is less than or equal to x in the question, they have strictly mentioned it has to be less than or equal to x, right? So this is fine. Now we will skip dp of I plus 1 into j, nothing but this will be min of dp of I plus 1j dp of ij. So there is no c of I into n minus I present, right? So this is fine. We'll be tracking the largest j that stays this one less than or equal to x basically, right? So this is fine. For the example, we have 3 4 1 1 1, right? So we will be choosing 1 and 2, right? So total will be quite obviously when we apply the formula, it will be 3, which is less than or equal to 4. So k x we have been given 4, right? So this one, this is fine. This is fine. This is not required currently. So we will be choosing 1 and 2, and total will be 3. Then this will be less than or equal to 4 basically. Yeah, because x we have been given 4, and 3 is less than 4. So answer will be basically 2. We have considered 1 and 2, right? So answer will be quite obviously 2 here in this case, right? So I hope the approach part is completely clear, man. The output that we got here is 2, which is equivalent to the output that they have given for the example 1 within the question. You can just try it out in the same way for the example 2 as well, right? So for the example 2 or for any example that you can consider, right? So now as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part, right? So what will be the time complexity here? Just give me a second, 1 second. Yeah, the time complexity would be big of n square, right? So when I say n square, we'll be going with the two nested loops over days and accepted, right? So accepted in the sense accepted count update, right? So two nested loops over days and accepted count update each state once, right? So this is fine. Now what will be the space complexity then? Or space complexity would be big of n square as well, because we'll be making use of the dp table of size n plus 1 into m plus 1, right? So we'll be purely going with the dp table of size n plus 1 into m plus 1. That will lead to the space complexity of big of n square. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n square and n square respectively, right? So now as we are completely familiar with the complexities and the approach part, let's quickly discuss the this one. I mean, let's start writing the code, right? So just give me a second here. So let's start writing the code, right? So I'll be making use of the this one, fast input and the output along with the different utilities, right? So I'll just go with import java io star. This is fine. And again, let me go with import java dot util dot star. This is fine. Now let me go with a public class main. So within the main class, what I'll do, I'll just go with a main, right? So main method basically. This is fine. Uh, so let me make use of the input output exception as well, or else it will throw the error. So I'll just go with throws input output exception here. This is fine. Now within the main method, so I'll be going with a custom input reader. So I'll just go with IR. So this one will be equal to new input reader. So this one will be new file, this one input stream actually. Yeah, let me go with input dot text. So this is fine. This is fine, man. Next, let me go with a print writer, or else I would have went with a buffer writer directly. This is fine, man. Print writer output. This will be new print writer, new buffered output stream, and new file output stream. This one will be let me give output dot text. So this is fine. Now let me do one thing. For the n, so we have to go with the n and x first, right? So just go with n equals dot next here. So in the input we have been given n and x, right, in the first line. So I'll just go with next int here. Both are integers basically. So x equals same thing. I have dot next int. C, this one will be new int of this one n. This is fine. This is fine. Now let's go with the for loop, because we have to read daily consumers, right? So we have to read daily, not consumers, basically consumptions basically. So I got confused here, sorry. We have to read the daily consumptions. So let's do one thing. Let me go with the iteration part here. So just give me a second, 1 second, man, here. So this one will be for I equals 0, I less than n. So this will be I plus plus. So this one will be c of I equals ir dot next int, right? So this is fine, man. Next, let's do one thing. Let me go with the uh, as I've said, we'll be making use of the DP, right? So we have already discussed that we'll be going with the DP array of size n plus 1 into n plus 1, right? So we have already discussed this one. This one will be in DP equals new into n plus 1 into plus 1. That's it, right? So this is fine. Now let's go with the for loop. We have to initialize, right? So this one x plus 1 part. So just give me a second here. Yeah, we have to initialize x plus 1. This is fine. We are just filling the DP, this one, individual this one. So I can just write it on this way. For DP, this is fine. I'll just go with arrays dot fill d comma x plus 1. So let me go with the initially, as we had discussed in the approach, we will be initializing DP of 0 0 to 0, right? So this is fine, man. Also we need maximum, so I'll just initialize max variable to 0. This is fine, man. Next, so we have to iterate over days. Also we have to try accepting the this one, what do we call, try accepting to move from j to I plus 1. So we have to iterate over days, and we have to try accepting to move from j to j plus 1. These things we have to do. Further, we have to go with the cost to take day I animal. Lifetime cost will be c of I into n minus I. We have considered this one within the approach, right? So if the approach, I also said that if the total food used stays within the x, then we have to update the best cost for I plus 1 and j plus 1, and finally update the answer candidate, right? So that's what we will be doing here now. So nested loops will be making use of, as I've said, right? So now I'll just go with for I equals 0. One more for loop. This one will be j equals 0, j less than n. So this will be j plus plus. So within this for loop, so I'll just go with a variable val, nothing but the value. So this will be dp of ij plus c of I into n minus I. So if value less than or equal to x, dp of I plus 1, j plus 1, this one will be math dot mon, sorry, I'll keep small a here. So math dot mon of dp of I plus 1, j plus 1. Also we have to pass the value, right? So this is fine, man. Now finally we have to update the answer candidate. Nothing but here in this case max equals, I've considered math dot max. Let me pass max comma j plus 1. So let me come out of this one entirely. Now let's go with the iteration part, right? So for we have to skip, right? So accordingly with the approach, so this one will be int j equals 0, j less than or equal to n. So this one will be j plus plus dp of I plus 1. So this one will be j. Let me assign this one to math dot mon of, so this one will be dp of I plus 1 j as well as dp of I and j. This is fine. Yeah, we are almost done with the coding part. So now we have to print the maximum number, right? So this one, what do we call that one? I completely forgot this one. We have to print the maximum number of animals that is accepted, right? So that's what the question states. And finally, we have to flush and close the output. These two things we have to do. So I'll just go with out dot. Let me go with a println here. So let me pass max here. This is fine. Also, we have to flush and close the output, right? So either we can go with a close or flush. So I'll just go with close for this particular problem. This is fine. Now let me come out of this one. So here we have made use of the input reader, right? So this one I said that we'll be making use of the custom input reader, right? So let me copy paste this one. So this is not related to the logical part. This is purely related to the fast, this one input output part basically, right? So let me paste this one over here. Let me remove one this thing. This is fine. So just give me a second here. Yep, this is fine, man. Now, before checking the code with different inputs, let me do one thing. Sorry, let me copy paste the signature starter template. So now let me do one thing. Let me come here. Let me copy this one. We have to get the output too. Let's check. So here we have something. Error expected. Oh yeah, new file of input stream I am considering, right? So here this one has to be. mm, New file input. So this one is not new input reader, man. This one has to be input stream. So new input reader I have given. So here file input stream it has to be. So let me go with file. Just give me a second. File input stream. Buffer output stream. This is fine. Let me run this one now. Huh? Where? Line number 24 again. New file. So let me delete this one. Sorry. This is fine. Now let me run this one. Yeah. Yeah, I have missed the semicolon here. So this is fine. But on this one, we have to get the output. No, text no such. Let me go with just. We don't have to go with input or the output text. This is fine. If I run this one again. What? error, no suitable constructor found for input file stream. Just give me a second here. So we have to pass input if we want the file, this one, in the form of file. We have to pass the this one file, input.txt and output.txt here. If I passing that one, I'm not getting the correct ones. This one output. So just let me check here. This one output and input. So let me do one thing. Let me copy this one entirely and paste this one here within the code. Let's see whether this works for this file based input and output. We are going with a file based input output, right? So let's check whether this works or not. If it gives error, then we can remove that one and just go with a buffered reader system.in and system.out. I can just give. Let's check. This has to work. Let's see. I hope this works, man, so that I don't have to change this one again. Yeah, this is showing accepted in the this one. What do we call? Toast actually, right? So the verdict that we got here is accepted, right? So this was the problem. So in the compiler it's not showing actually. So this is fine, man. So we are just getting the this one output in the format, in the file format, basically input.txt and output.txt. That doesn't work on the compiler basically, right? So this is fine. Now we have went with a pure dp. This was just related to the input output, so I didn't type this one, right? So this is pure logical part. So we have made use of the DP basically, that we have already discussed within the approach, as well as while writing the code. Code also I have explained, right? So I hope the coding part is completely clear. I mean solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.